Good morning to everyone. Welcome back to class 9 mathematics. We are going to continue with the same chapter, chapter number 8, Heron's formula, part number 4. This is going to be a new section, area of a triangle by Heron's formula. So now we are going to see what is Heron's formula, why the name of the chapter is given as Heron's formula through this section. So in the last video, we have checked whether different types of triangles areas can be found by using the basic formula, but we were able to prove yes, right angled triangle, equilateral and isosceles triangles, we are able to do it, but not possible for scalene triangles unless we know the height of the triangle. And also we understood and learnt a formula for right angled triangle and for equilateral triangle. In this video, we are going to learn a new formula for triangles given only its sides and height is not given. We are going to understand the formula and also apply this. The same formula we will put for the right angled triangle, equilateral triangle and isosceles triangle and check whatever result, whatever answers we got by using half BH, whether we are finding the same answer using this formula. So in the previous video, this page is not applicable, so I am removing it. Okay, yeah, now we will see this. That particular page you can ignore, not required. I'll just put that also so that you don't get confused. Okay, this is clear now. Heron. There was a person by name Heron who was born in Egypt, in Alexandria in Egypt around 10 AD, that is 2000 years back. He worked in applied mathematics. His works on mathematical and physical subjects are so numerous and varied that he is considered to be an encyclopedic writer in these fields. His geometrical works deal largely with problems on mensuration, written in 3 books. Mensuration means it is the calculation of area, volume, like that, surface area. Book 1 deals with the area of squares, rectangles, triangles, trapezoids, various other specialized quadrilaterals, the regular polygons, circles, surfaces of cylinders, cones, spheres, etc. In this book, Heron has derived the famous formula for the area of a triangle in terms of its 3 sides. So you can also go through this, just general information about Heron, the mathematician who has given the formula to the world. So let us now move on. You can just go through if you are interested in knowing about him. You can also Google and find out further about him. Let's move to the next page. The formula given by Heron about the area of triangle, it's also known as Hero's formula. Area of a triangle is square root of s into s minus a into s minus b into s minus c, where s is the semi-perimeter and a, b, c are sides of the triangle. So when we see practical examples, you will understand better, but for the time being, you can note down this word by word, what is their area of triangle, so that you will be repeatedly using this everywhere. But proof for this will be discussed in a later chapter, possibly in this class or in a later class, that we will see when it comes. Now you have to only understand the formula. This is very easy to remember. So you can, once you write and 1 or 2 examples you solve, you will be able to understand this formula and you will not forget at all. Now we will move to the next page. Since the semi-perimeter is calculated by adding the sides, its unit of measurement is centimeter. So whenever you write s equal to a plus b plus c by 2, you should write so much centimeter. And in area calculation, it is, you can see centimeter, 4 times centimeter will be there. S is 1 centimeter, s minus a 1 centimeter, s minus b, s minus c. Like this, there are 4 centimeter. That means the square root of centimeter to the power 4 equal to centimeter square. That is, if you square root of centimeter power 4 is centimeter square or millimeter square or meter square. So that's how we can also understand the unit of measurement. Let us now apply this formula for different types of triangles which we saw in the previous part and check whether we are getting the same answers. We will move to the next page. So, right angled triangle, you can see the formula. It's all simple. I'll explain one. The subsequent ones you will be able to see yourself. All the three sides are given. So, I am finding S equal to 13 plus 12 plus 5 divided by 2. 30 by 2 is 15 centimeters. So, note you have to mention the unit here, centimeter. It's very important. Then area equal to square root of the same. You have to follow the same steps so that you don't make any mistakes. And then square root, I am writing S is 15, 15 minus 13, 15 minus 12, 15 minus 5 and then equal to 15 into 2 into 3 into 10. It is how much? 900. Square root of 900 equal to 30 centimeter square. So, we got the same answer. You can check the notebook where you are noted down. Right angled triangle area ABC, it is the same. Similarly, I will go a little fast now. The same steps, all same steps. So, we are getting 25 root 3 square centimeter and it is correct. Now, you can pause the video, note down these steps. These steps are very important. One more step will come, one or two more steps will come which I will explain when we see that. But for the time being, you can note these steps. These are simple formula, simple dimensions. A little complicated, we have to do a little more, one or two more steps that we will see in the subsequent pages. Now, we will move forward. Isosceles triangle, same, everything is same. So, here also 12 centimeter square is the answer. So, we have got it correct. We can note that if you know the lengths of all the three sides without doing any further steps, like whether which is base, which is height, whether calculating height, nothing is required. Straight away we can apply Heron's formula for finding the area. We need only the length of three sides for using Heron's formula. That's how this is extensively used. Always we will know the three sides of any triangle. With this we will be able to find the area of the triangle. Go to the next page. So, now answer should be in simplified form. This is one additional step which I am telling now. As shown in equilateral triangle example, inside square root find factors for all numbers, that is 15 was there. So, 3 into 5, take 1 out of every 2 same factors outside the root. There were 2 5s out of 4 5s here, 4 5s were there. So, I have taken 2 and multiply the remaining factors outside. You can, next paragraph I have given an example. This you can just see, listen to me, multiply the remaining factors outside, that is 5 into 5, I have taken 2 5s outside equal to 25 and inside the root here there is only one number 3. So, hence this is not applicable and write the answer 25 root 3. Let us see an example, you will be able to understand. Simplify square root 22 into 2 into 21. Suppose if there is such a complicated numbers inside the square root. So, first step what we should do, we should see the factors. Now, you see 2 into 11, 3 into 7, 2 is 2, 21 is 3 into 7, 5. Better to put brackets also so that we don't miss any number, we don't make any mistakes. 25 I have broken into 5 into 5, next 3 and 5 no further division. 42 is 2 into 3 into 7, 5 no division, 4 is 2 into 2. So, I am putting the square root. Now, next step is regroup in such a way, bring all the numbers together, same numbers together. So, I am putting square root 2 into 2 into 2. So, how many 2's are there? 1, 2, 3, 4, 5 2's are there. I brought 5 2's together. Then 3 3's together, 5 5's together, 2 7's together, 1 11 together. So, that we can just count and see whether all are correct. Once or twice cross check and then come to this. Then what you should do, underline pairs. There are 4 2's are there. I have underlined all the 4 2. Then 2 3's I have underlined, 4 5's I have underlined, 2 7's I have underlined. That is, even numbers you underline, odd number leave it as it is. Now, the next step is, we will see the next step. Wherever pairs are there, that is, there are 4 2's, take 2 out of 4. That is, for every 2 numbers, 2 same numbers, take out 1. So, as I have written in the previous paragraph, since there are 4 2's, take 2 2's out, leave 1 2 inside. There are 3 3's, take 1 3, leave 1 3 inside, 5 5's, so out of 4 you take 2 5's outside, leave 1 5 inside, 2 sevens, take 1 7 outside and 11 leave it as it is. The reason, you know, square root of 2 into 2 is 2. Square root of 3, 5 into 5 into 5 into 5. There are 4 5s are inside and square root means equal to 5 into 5. All of you know this. So better to do these steps so that we don't make any mistakes. Let's go to the next page. You can note down these points before going to the next page. Okay, here itself I have written. Now answer, you multiply outside and inside. So inside is 330 square root and outside is 2100. So these steps are very simple steps. This will help you in not making any mistake, as well as in any case the answer has to be in simplified form. So when we go to the next example, I will explain you one example so that we will know further whatever we have done here, you will be able to understand thoroughly. So in this part we have learnt Heron's formula and also verified for different types of triangles discussed in the last part. We found all are correct. Next video we are going to practice some examples to understand Heron's formula even better. Now we saw only the formula, we saw some simplification. So all the steps we will incorporate, we will see in the next part. 5 questions are there. Note down all the questions. Pause the video, note down the questions, thoroughly understand and then attempt. That's all for this video. Thank you.